Okay. All right. Well, I'll start it over again, and I'll let you control it.
Sounds good. So we're good to go whenever you are, Hayden.
All right. Here we go. All right. Well, thank you everyone for your patience. I appreciate this. Welcome to our National Weather Service Boston Norton webinar, and this event will be on the February 19th snow squall event that we had a few weeks ago. Just a reminder, everyone is on mute. Use the chat box for questions. We'll answer them at the end. All webinars are posted on the National Weather Service Boston YouTube channel, and we always love your feedback. So please email Joseph Delacarpini at noaa.gov after this webinar. And at the end of this, we will do a briefing on the upcoming weather, including some active weather tonight, maybe even some thunderstorms, and maybe a bit of snow on Wednesday. All right. So please check our webinar page or social media for the latest schedule, www.weather.gov/Boston/webinars. We actually have a couple upcoming. One is going to be on Thursday, March 10th. That is going to be a review of the February 4th Wintry Mix event. If you remember that event, that was when we had a rain change to freezing rain and sleet. We didn't have much snow, but we had a significant amount of icing, and roads were quite hazardous that afternoon and evening. Also coming up a week from this Thursday, March 31st, we will be remembering the April Fool's blizzard 25 years later. Hard to believe, but that was one of the biggest storms ever in Boston. We had over 2 feet of snow, really unusual time of year to get that, but it was quite the event. So we'll be discussing that in some greater detail a week from Thursday. Also, March is Citizen Science Month. Participate in scientific research and share data to increase scientific knowledge. Everyone is welcome to contribute to data monitoring and collection programs. And some of these include, if you have an interest in severe weather, weather.gov/BOX/Skywarn. A lot of volunteers submitting severe weather reports all across the region. That really keeps us up to date of what's going on and gives us an idea if our warnings are verifying what we're seeing on the radar is matching what is actually being observed on the ground. The MPing app for your cell phone, that actually uses GPS and maps out where you are, and that will allow you to submit a report, say a rain or snow or sleet or freezing rain, and that helps us out immensely too. And lastly, our CocoRoss program, that allows ordinary citizens, just volunteers, to submit rainfall and snowfall amounts across the region. And again, that is another avenue of information where we can really improve our forecasts and disseminate the information quickly to you folks. And the presenters for tonight's webinar, myself, again, my name's Hayden Frank. I am a lead meteorologist. With me is Tori Gucher, another meteorologist, and our newest lead meteorologist, Andrew Locanto. And I'm actually going to be passing this on to Andrew very shortly. We're fortunate to really have him on this presentation. He is one of the primary developers of this program. He's done a lot of research in snow squalls and how they develop. So without further ado, I am going to turn it over to Andrew.
Yeah, good evening, everyone, and thank you, Hayden, for that, that introduction there. So let's go ahead and sort of dive into this sort of event here on February 19th. In terms of the highlights of this this event, it was really well forecast, and you know, one of the things we use when we look at you know, sort of the meteorology and forecasting this, really anything, is high resolution models, and those are really sort of fine scale sort of models that you know, not necessarily the best, but they tend to accurately sort of predict things fairly well. And in this case here, this was no exception. It did a great job with the timing and the location of the snow squalls, you know, anywhere up to 2 days before, anywhere between 36 and 48 hours. And because of that, you know, really good agreement in some of these high resolution models, That allowed us as forecasters to be more confident in terms of the messaging as much as 1 to 2 days before this event unfolded. And the sort of the next bullet point here, during warning operations, webcams and Google Map traffic were relied upon to maintain situational awareness. I'll go into the science of sort of snow squalls here in a few minutes, but the overall idea is we've designed these products called snow squall warnings, and they're really sort of meant to convey especially to folks that are driving, or if you're, it's primarily a transportation sort of impact. So obviously webcams and Google Map traffic can be really helpful to sort of pinpoint some of those sort of impacts that we see with these sort of snow squalls. So that was a major decision point with issuing snow squall warnings versus a more a generic sort of special weather statement, just to raise awareness of some of these snow squalls. Really, the webcams and the Google Map traffic is especially important to maintain situational awareness for these, because what happens is when you look at a Doppler radar, the further away from the radar you go, the higher up in the cloud that you're looking. And a characteristic of these snow squalls is that they tend to be sort of very shallow. A lot of times the cloud themselves, extends to about 10,000 feet higher, or sometimes even less than that. So the further away you go, the more difficult it can be to really see these on radar. So that's why we describe this as sort of overshooting at farther ranges, because what it can do is can sort of lull you into this idea that if you're an avid radar watcher, and you're seeing these things start to weaken, all of a sudden they start to increase in intensity again as they move towards the radar. That's not necessarily the case. It's just the fact that the radar is what we call overshooting those sort of snow squalls, because they're, as I mentioned, they're sort of smaller in terms of vertical depth. Again, only about 8 to 10,000 feet. Another sort of challenge that we did have with this particular event was that we were sort of dealing with, unfortunately, a dissemination and communications outage that prevented some of our snow squall warnings from being transmitted. And this happened around 4 o'clock that day. And unfortunately, we had to sort of get creative as far as getting this message out. So we started to aggressively use social media to start to show some warning polygons and radar imagery, and then sort of your local TV meteorologists also assisted by creating their own sort of graphics, and a lot of them had to be sort of hand-drawn. That's sort of an unfortunate circumstance of this communications outage, and again, we do sort of apologize for that, and but we did try to do our best we could. So moving on to the next slide, we'll start to go into more of the science behind these snow squalls. So here's an image that just shows a car that's flipped on its nose, and essentially what are snow squalls? They're intense but limited duration. They tend to be about 30 minutes in terms of the heavy snow itself. Again, these snow squalls, again, they're intense periods of moderate to heavy snow. Again, approximately 30 minutes in duration, and they're accompanied by strong and gusty surface winds. And what that'll do is that'll set up conditions that may resemble sort of like near blizzard conditions for about 15 to 20 minutes in time. So that's sort of the main impact with these. Again, it's not so much the snow accumulation itself, it's just the fact that the visibility can go from clear to all of a sudden it's like a whiteout for 15 to 30 minutes. And you can imagine if you're driving how that can sort of help to sort of disorient you and really be a potentially hazardous situation for individuals that are driving. And when you factor that in with what we call rapidly falling temperatures, in conjunction with the snow, it can produce a condition called a flash freeze, which we'll get to here in a minute. But what that'll do is, with the low visibility and the fact that the roads are freezing up like that, it can make for a very difficult and very dangerous sort of travel conditions. And that's sort of the motivation behind the snow squall warnings. Next slide. So again, a little bit about the science behind snow squalls. They're effectively actually their wintertime convection is, think of it. You can think of it that way. They're thin bands of heavy snow. Again, they're fairly brief, and they're driven by a lot of the things that we would use to predict summertime thunderstorms, instability and strong lift. In this case, by a cold front is more commonly where you see these snow squalls. They can have very, very high snowfall rates. Up to 2 inches in 30 minutes is not uncommon with these. So you can just imagine when you get those kind of snow rates that the visibility will also drop really dramatically. We've got a few images of those coming up here in a little bit. Snow squalls are basically, they're miniature blizzards. In a matter of minutes, probably cloudy skies, as you see in some of the images here on the far right, can go from basically a clear day to all of a sudden heavy snow with wind gusts of 30+ miles per hour and visibility less than a quarter of a mile. So as you see some of these images here, and we'll have a video actually here which shows it even better. But you can see the example, but there with all of a sudden, again, there's the cars there with the basically clear visibility, no restrictions there, and all of a sudden you can see some of the video images there, indicating just how quickly the visibility drops. Again, this is more of a transportation sort of hazard. Next slide. So I mentioned before what we call this sort of flash freeze, and this is a common hazard that's associated with snow squalls. And what happens is snow falls on the pavement. Oftentimes the pavement is above freezing because of, for example, like temperatures could be warm enough, just marginally enough to support pavement temperature that's, close to or just above freezing. And what happens is the initial snow, it melts on contact. But what happens thereafter in the minutes behind the snow squall is that temperatures fall quickly, and the road temperature as well will fall below freezing as well as those air temperatures start to fall. And what happens is there's a water, the water that was on the wet pavement before, all that freezes and becomes a thin but a very dangerous layer of ice. And you can imagine that if you're driving on a road, all of a sudden you see the visibility start to drop, and there may have been car accidents ahead of you that you just can't see. So your reaction time is also cut significantly shorter if you have in sort of a chain reaction sort of traffic incidents that we see with these, where we have accidents that happen because drivers just don't have the time to react to accidents that may have occurred while the snow squall and the whiteout conditions, again, disorient some of the drivers. So in that case, the combination of the whiteout conditions and the flash freeze can be very dangerous, and that's really what we're trying to target with these snow squalls. Next slide. So I mentioned before about how snow squalls can carry similar characteristics to summertime thunderstorms, and obviously the difference is that you have temperatures that support snow as opposed to real torrential rains as we see with thunderstorms. But snow squalls themselves can have thunder and lightning with them too at times. I believe in this event here we had some lightning that was reported in some areas in Metro West Boston, also towards central and western Massachusetts. So you can get lightning with these, but the main concern with these wintertime snow squalls, again, is the visibility reduction. It's a brief but it's an intense period of heavy snow. Again, conditions that resemble blizzard conditions for a brief period of time. again, with whiteout conditions, they're really dangerous for travelers. And the nice thing is with these snow squall warnings is that what they do is they'll trigger those wireless emergency alerts that you'll see in cases, for example, for flash floods or for tornadoes, for tornado warnings. Snow squall warnings will activate wireless emergency alerts as well. So when you're on the road, you'll hear that very creepy buzzing sound that indicates that there's a snow squall warning in effect, and you should consider pulling off to the side of the road or delaying travel if you're trying to go outside, to go into your vehicle, just to keep yourself from an unfortunate sort of situation on the roads. Next slide. So here's an example of, this is actually during the event itself, of this sort of snow squall line as it moved across southern New England here. And you can see this, in blocks in blue are the snow squall warnings that we had issued. And again, some of these unfortunately didn't get transmitted out to the world because of this communications outage that we unfortunately had to adjust to. But you can see the really intense sort of reflectivities there. Those really deep greens and even some orange returns there, sort of 30 to 40 dBz is what we sort of measure reflectivity by. And that just indicates a really intense snow squall, and that just bands of brief heavy snow. Again, you could see how small in terms of the real estate that's covered. It is moving from west to east, but if you look at just the duration, it's maybe a few miles across in terms of its sort of east-west length. So it's a really brief period, but when it comes down very very intense for, again, a short period of time. Next slide. And again, this is an example, just an image again of the radar, just showing just the reflectivity itself, again showing those really intense reflectivity cores that we see along this sort of squall line here. But also we also see the snow squall warnings painted in these blue boxes that extend from southern New Hampshire all the way down into the Long Island area and into southern Connecticut as well. Next slide. So this is an example of some of the images that this is a loop of actually the webcam out of Springfield, and as you might have seen, and we'll let this play a little bit more, but you can see all of a sudden the visibility went from basically clear conditions to all of a sudden it's just a pure whiteout for about in this case here, this was a time lapse, so sort of it's sped up here a little bit, but you can see here again, just as this plays through, there's that sort of wall of snow as it comes in, your visibility drops, and at this point it's very dangerous to be driving. And as the snow squall moves across, eventually you encounter some clearing, but that takes about as much as 30 minutes. Next slide. And again, this is from Sarah Obleski from WBZ in Boston, and this is a time lapse of the snow squall moving through the greater Boston metro area with the Prudential building there pictured in the right in the center of the image. And again, just playing this through again. Here comes the snow squall line itself, and you can see that wall of snow that comes at you. Again, visibility goes from clear to pure whiteout for about 15 to 30 minutes, and then it will quickly start to improve. But by then, the damage will have been done. There'll be likely have been some accidents, which again we want to try to avoid. But ultimately, we want to try to make sure people understand what these snow squalls are, and sort of take the appropriate actions to consider delaying travel, or consider pulling off to the side of the road until the squall is cleared. So here's an example of some images of the snow squall. This is from Marblehead, courtesy of Thomas Adams. Pictured here again, you could see just how they look a lot like thunderstorm clouds, don't they? And but unfortunately, they're pretty shallow. They're maybe about 8 to 10,000 feet in terms of depth. Next slide. And finally here, this is just some useful resources for you in terms of if you want to monitor these in real time. We have some web links here that cover the traffic map from Mass DOT. We also have some conditions if you're looking to watch snow squalls coming into Western Massachusetts. We have the New York State Thruway webcams, and then the New York State Mesonet is another good source. And with that, I will pass it over to Hayden, I believe. We'll be covering the forecast.
I will pick it up from here, Andrew. Thank you very much, Andrew, for getting us through that. Andrew is a very humble man. He played a really integral part of getting snow squall warnings to where they are today. Maybe he can talk a little bit about that if we have some time at the end. So this is Tori Goshi, and we're going to jump into the forecast and analysis part of this presentation. So we'll start from the top down. This was just a quick screen grab of the 500 millibar heights and vorticity from the NAM, and that was a forecast image here, but showing that we have a sharp upper trough, and that's helping to provide some forcing that we'll need for those snow squalls. You can see there's a lot of vorticity on the eastern edge of the trough as it's going to be sliding through southern New England. So that's a look from the top. And at the bottom, we have a area of low pressure just in about northwest of Montreal, heading towards Quebec City. Up here, where you can see the surface low is about 1,004 millibars. This blue line draping down to the south and west, you can see where you have these little nudges in the isobars. That is showing where the Arctic front is going to be coming through. Once again, this is a forecast. This was the NAM looking at the mean sea level pressure and the precipitation. You can see here in the light blue, the darker blue showing a little bit of more precipitable water. That was just about 1/10 of an inch. So there wasn't a ton of moisture with this system, but enough to cause some havoc on the roadways. Rodney Chai, who introduced me to CIPS, that is the Cooperative Institute for Precipitation Systems. This kind of shows us when we have the potential for snow squalls. The snow squall parameter, it's a unitless parameter, but shows that there's some pretty strong signals out towards western portions of New York. As Rodney would say, this would be about a slam dunk. But this was looking at 4 p.m. on Saturday, and this is 33 hours into the forecast. So looking well out beyond a day, we were getting some pretty strong signals that we were going to be looking at some snow squalls pushing from western New York into southern New England, and even making it all the way, to the coastline, from Cape Ann to Cape Cod to the islands, that there was a high likelihood that we could be dealing with snow squalls pretty much during the afternoon hours on Saturday. And the HREF hourly snowfall and P-type forecast, that started off with the day with maybe a few isolated snow flurries that was showing some reflectivity earlier on in the day. And we did have a little concern whether or not temperatures were going to be able to support either light snow or light rain. And as Andrew talked about earlier, we are also concerned with flash freezing. And at one point, temperatures were looking like they may be just above freezing, so it may allow for some light rain in this leading edge first. And then we were concerned with the cold air that was going to be coming behind in the Arctic front that would enhance that flash freeze. But here's a look at the forecast. It was showing a bit of some light precip out ahead, and then this was kind of the meat and potatoes, that Arctic cold front bringing through the snow squalls. And we were anticipating they were going to get to western Massachusetts, western Connecticut, the Hudson River Valley area by 1 o'clock, marching through western Connecticut, central Connecticut and central Massachusetts between 3 o'clock, and then exiting out to the Providence, Boston metro by, say, 5 o'clock or so. The NAM forecast sounding for Worcester, also known as ORH, was showing some pretty steep lapse rates in the lower levels, pretty much up to 3 kilometers. And as Andrew alluded to, these storms, these snow squalls, are very low top, unlike our summer convective cousins where they'll blossom all the way up to 35,000 feet here in southern New England. Also, when you want to have that convection, you want to have some instability. And unfortunately, there wasn't a heck of a lot of CAPE. That's a unit of measure that we look at for instability. There was about maybe 25 joules of CAPE. So we're going to look at what else kind of played in and gave us that lift on that afternoon. So leading up to this, we had some bit of warmer temperatures, the 30s out ahead of this Arctic front. Behind it, temperatures were in the teens. So frontogenesis pretty much gave us that lift. We had that contrast between the slightly, we'll call it warmer temperatures in the 30s, not really warm, but back behind the Arctic front, we have temperatures that are going to be in the teens and single digits. So there was a pretty sharp gradient of temperatures, which helped to give us some of that lift. And it was kind of being pointed out. You can see this area of red showing where we would have some of that lift going on by 1 o'clock, pretty much from the capital region of New York into northeastern portions of Pennsylvania. By 4 o'clock, the best lift shifts off to the east towards pretty much southern New England, and then to the Cape and Islands by 7 o'clock. Not sure if you're catching the trend here. This is many different aspects of the forecast that we're looking at that's showing that pretty much between 1 and 7 o'clock is going to be game time for this snow squall setup. So additionally, we had temperatures that were allowing for some pretty steep lapse rates. These are some of the low-level lapse rates, and you can see anywhere from 8.5 degrees Celsius per kilometer. Even 7.5, that's decent enough to get things going during the summer, and let alone during the winter. And once again, you see the trend: 1 o'clock, 4 o'clock, 7 o'clock. You see it shifting off to the east. So we're looking at, we're going to have those steep lapse rates that are going to help to continue with the that convection to keep those snow squalls going pretty much all the way from Albany to P-Town. And we had plenty of moisture. All this green that we're looking at is showing low-level moisture, so pretty much saturation. And we're pretty much almost saturated across much of southern New England, all the way back into eastern portions of New York, where we have our low-level moisture between 85 and 90%. And that moisture is shifting along pretty much at the same clip. So we had some pretty good indications that we were going to have snow squalls on this day. And this is another lake effect parameter, once again showing, you've got the wind barbs showing where the wind is going to. We had some pretty good convergence happening, and that is where we're seeing the areas of red where we had some of the strongest convergence of that low-level winds. And it's pretty spot on where it's following that snow squall track from eastern New York right out into the coastal waters of southern New England. And when we were talking about the flash freeze potential, this purple line right here indicates temperatures at 32 degrees near the surface. Back behind here, we have temperatures in the 20s, 24 degrees out towards, say, the Finger Lakes region of New York. And then as you work your way further east, we have temperatures, would be then 34, 30, like the mid and upper 30s out towards the Cape and Islands. So we have a very tight gradient right here, once again, aiding in that lift. Also, the concern is as the cold air starts rushing in behind the Arctic front, here's 4 o'clock. That freezing line is all the way from Hartford to Providence, just to the Metro West area of Boston. And by 7 o'clock, it's pretty much at the Cape Cod Canal and elsewhere just off the coast. So we have the rush of that cold air coming in behind, and our concern is, hey, if the roads are untreated and wet, we could be looking at some freezing conditions. So with all of this confidence, we got out this one-pager from our office. This goes out to our local EMs and pretty much spelled everything out, saying, hey, we have an Arctic cold front that is going to be coming in on Saturday afternoon, likely going to reduce your visibility, going to bring in snow squalls, and additionally, icy spots along with the potential flash freeze is possible because of any residual road moisture. We gave them the timing of roughly 1 to 2 o'clock in the afternoon, entering in western Massachusetts and Connecticut, 3 to 5 for the Rhode Island and eastern Massachusetts area, and then between 5 and 7 for the Cape and Islands. We gave them, hey, these are the hazards and impacts that we're going to likely see. Icy spots, flash freeze possible on the road, especially if the pavement is wet because of the plummeting temperatures that follow after the Arctic front passage. Now, we didn't have any alerts out at the time. We discussed that we'll likely put out a special weather statement the next day to once again remind people that, hey, we do have the threat for snow squalls coming in this afternoon. But one of the challenges, very much similar with a summertime thunderstorm or squall line, is that, yeah, we may have some severe weather along it, but not everybody's likely to see severe weather. It's not like the entire line is producing severe weather from start to finish. So our challenge here is, how widespread will that snow squall be in the flash freeze, excuse me. And then we give them this post-outlook event afterwards, just because, hey, there may be some isolated outages. Just want to let them know what they're working with when going into Sunday. So we issued this first Friday afternoon, was issued at 3:15, about 24 hours before our first warning. And this, once again, helps to ensure consistency in messaging between the television meteorologists and our local emergency managers. So we utilize social media a ton. We use this loop just to show the temperatures, how they would start off around 1, 2 o'clock. And as we head into the afternoon, you can see those temperatures plummeting. This is just helping to visualize how people can see that the temperatures are going to drop throughout the afternoon. And Rodney and I actually created this graphic just to show the very basic, hey, there is a high-end moderate chance of snow squalls possibly happening. And if they do happen, it's going to be a high impact event with flash freeze, blowing snow, and near zero visibility. And we thought it would be simple enough just to put on these lines saying, hey, pretty much from Hartford just to about the Franklin-Worcester county line, 1, 2 o'clock, it's going to be in your area. By you get to 3, 5, anywhere from Worcester to pretty much Lawrence, 5 to 7, you got pretty much Swansea all the way up to Cape Ann and so on and so forth. So we did utilize social media the day before to get that out. We also utilize social media to talk about what snow squalls are, how they form, what type of impacts, how we warn. I won't dive back into this. I know Andrew talked a lot about it. So that afternoon, our first snow squall warning did go out right around 3:30, and that was pretty much for almost a good chunk of central Mass. You had all of central and western Franklin, Hampshire, and Hampden County, and then we extended it further south a little short time later. Now, this was an important thing to get out because we needed to get those emergency alerts, the WIA alert, going off. And this is what people would see on their phone. Now, the WIA would be displayed on their phone, and it's great for drivers because it's alerting them, hey, this is coming your way. And as Andrew said, maybe you want to pull off to the side of the road or maybe delay your travel, knowing that that snow squall is coming your way. Social media was a great friend to us because it gave us some ground truth. Colton Flint sent us this one. It was a video pretty much showing near whiteout conditions. And then Dylan, he was working out in Worcester, and he was showing a major thoroughfare that was pretty much near whiteout conditions. And by us able to see that, we know that our warnings are, verifying, and it also gives perspective to others that are in the area or maybe ahead of the squall so they see what these conditions are going to be like. Now, as Andrew did allude to, we had a snafu with our comms outage, and we were lucky enough to be able to still have our products still in-house show our polygons. So at 5 o'clock, we had issued another snow squall warning pretty much from Nashua down through Lowell, Worcester, into eastern Connecticut, western Rhode Island. And this is about to impact pretty much the the core population of our CWA, where the density of population is somewhat the highest. So we were able to use social media to get these warnings out. And by getting these warnings out, our friends like Sarah from WBZ was able to take a look at what we had and hand draw on her own snow squall warning and get the information out there. That way the public was, well aware. We also use this phone in our office. It's a NAWAS phone. It allows us to call Mass emergency managers, Connecticut emergency managers, Rhode Island emergency managers. It was a little difficult because we had to talk county by county, what part of the counties were under the warnings. So that did take up a little bit of time on our end getting that out there. But that goes to show you some of the extra things that we had to do because of that outage. But we have to thank all of our partners from our local EMs, people like Mass Transportation getting the tweets out, and our private sector and our TV meteorologists that really went above and beyond to get those warnings out the door. So in conclusion, this snow squall event was, it was a bit of a head scratcher for us for a moment when we had the WIA capability issues, but it just shows how important the WIA is, especially for the folks that are driving down the interstate, because you're not going to know that you're in a snow squall until it's pretty much upon you. And by the time it's upon you, your only option is to quickly pull off to the side of the road, but then you're sitting there in the middle of a blinding snow event, and it's an unsettling and unsafe situation. Some of the good news, though, is that the mesoscale models were impeccable with this, especially with the timing and the location of the line, almost 36 to 48 hours out. And our forecast, messaging, and warning operations they went off really well. Using upstream webcams, as Andrew showed earlier, were critical. We were able to check out cameras in Berkshire County knowing that, hey, this is the snow squall coming through. We can see that it's clearly causing whiteout conditions. We need to prep a snow squall warning now pretty much for the Pioneer Valley. So as Andrew mentioned before, snow squalls are very low topped with shallow convection. So reflectivity will likely decrease as the snow squall, reflectivity will likely increase as a snow squall approaches the radar, but then will appear that it's weakening as it moves further away. So take that into consideration next time as you see it moving away from the Albany radar and it looks like it's weakening as it's heading into the Connecticut River Valley. Well, it's just being overshot with the beam, and we're just not sampling the actual snow squall. But despite the national communications issue, our team was creative and versatile with ensuring that our partners and the public were kept informed. And with that, we'll take any other questions. I think we had a few coming on in, and I'm going to turn it back over to Hayden. And I think Hayden will dive into some of the questions. I thank you all for your time, and Hayden, off to you.
All right. Well, great presentation, Andrew and Tori. Especially that conclusion, I really think that sums it up in the sense that these are, as we say, low-topped. And it can appear that they're weakening on radar, but in reality, the radar is overshooting them. And again, that's just another example of how important those real-time observations are in the field and how that can really help us do our jobs better. So with that, I will try to get to some of these questions before we have our little map briefing. So it looks like we have one in from Kevin. It says, are lake effect snow parameters used in operational forecast settings, and how do forecasters account for this? That's a really good question, Kevin. Basically, whether we're talking about lake effect or ocean effect, the same idea is involved in the process. And when we're talking about instability, that's key, whether dealing with snow squalls or lake effect or ocean effect type of snow. So we're looking for, do you have the moisture? Do you have the instability? Instability lift, that's what really key on for whether it be lake effect, snow squalls, or ocean effect type of event here. We also have a question here from Kevin. How do you convey the snow squall warning products most effectively to emergency managers and the public as a warning coordination meteorologist? Andrew, Tori, either of you want to take that?
Yeah, I can take it. Yeah, Kevin, that is a great question. So obviously, I guess the thing, at least from an emergency manager perspective, even the public too, in an ideal situation, we want to have these snow squall warnings, at least some educational or outreach in those sort of avenues. So that way, when you get those warnings, that you know how to respond. In other words, like if it really, again, as we sort of mentioned, snow squall warnings are snow squalls in general. They're basically a transportation hazard. In fact, aircraft, but from public's point of view, it's mostly trains and especially vehicles, people driving on the roads. So that's some of the messaging that we really want to try to highlight with these is that snow squalls, if you're sitting in your home, is sort of a wow, look at that, it sort of looks like a snow globe outside. But if you're driving, and that's sort of where it becomes especially dangerous, because you have these sort of whiteout conditions and the flash freeze potential that can occur with several of these snow squalls. That's a very dangerous situation for folks that are driving. And that's sort of the message that you really want to convey. And we have different ways to alert emergency managers to when a snow squall warning is in effect. Several of them do get the warnings as either through third-party applications, or in some cases we can even we can do a quick call to them to just let them know that snow squall warnings in effect for portions of this county or vice versa. So I think that's probably how I'd best answer that question. But that is a great question, and thanks very much for asking.
Yeah, great. Thank you, Andrew. And it looks like we've got a question from Steve here. What shows up in your models that makes you mention the possibility of thunder? I think we'll hold off on that because we'll be discussing that here in a few minutes with the short map briefing. So we will come back to that. Maybe take one or two more here before we get onto the briefing. Anecdotally, snow squalls, and question is from Tom, snow squalls and summer squall lines have decreased in frequency the last few decades. Could this be symptomatic of a warmer climate? Well, to be honest, I don't know if we could really confirm that they've diminished. It'd be hard to kind of make that a proven statement. There's always what we call microclimates, where certain things may change, that things may become more favorable, say in one spot versus another spot. But I don't really have any solid proof of that. I don't know, Andrew or Tori, if you have anything to add to that.
Yeah, this is Andrew. Again, I think the way Hayden sort of addressed that is probably what I would say as well. Like, we don't really have a good sense, even as far as snow squalls frequency is sort of, they are very sort of rare events in general. In general, you probably get maybe one or two events in a winter season. But it's so in that sense, it's sort of tough to really sort of tease out if there's any sort of connection with a sort of a warming climate and sort of snow squall frequency. It's sort of difficult to correlate that at this point, because we just don't have a strong sense yet as far as how frequent these are. But in general, you tend to average one or two a winter, but you can get sometimes more, or sometimes you can not at all. So it's it's sort of a tougher question to answer there, but that's nonetheless, it's a great question to ask.
Great, thank you for that question.
And the only thing I would add into that one is just Andrew was talking about the frequency, and it just reminded me when I was working that day, Rodney and I were curious, like, oh, when was the last time our office issued a snow squall warning? And it was actually December of 2019 was the last time that the office issued one.
Yeah, so definitely not a product that's issued quite frequently. So shows you the somewhat rarity of these type of events here. And the last one we'll go to is from Fred. This is more of a statement, and thank you for this, Fred. This is what we like to hear. A strong snow squall in Newton that day, waited for the storm to go by, thanks to the warning. Went to Brighton and very little snow there. So that's actually a great statement. We like to hear that, our warnings and the information we're getting out are making a difference. And your last point there, with snow squalls, when we talk about thunderstorms, in the same sense, you could have a big snow squall 2 miles to the north of you, and then a mile to the south of you, the sun can be shining, and you just maybe get a flurry. So it's not unusual to have those type of differences within these, what we call thunderstorm type of events. Even if there's not thunder or lightning, they're kind of driven in the same mechanisms, because they're feeding off instability, not so much when we get our regular, what we call synoptic snowstorms with a big low pressure throwing in moisture off the ocean. So these are kind of a different type of event than what we think of New England and our typical snowstorms versus these, 15 minutes of brief heavy snow squalls and then, back to partly sunny skies. So with that, we will go ahead and do a brief map briefing. I will, if you could give me control here, Tori. There we go.
You should have it now.
Okay. All right. Tori, can you see my screen?
Yes, I can.
Okay, great. So I figured I'd start off with, the SPC mesoanalysis page and just kind of take a look at some parameters that we often look at when we're forecasting severe weather per se. So let's go take a look at first the surface observations here. Temperatures basically, I know this is small, harder to see, but temperatures basically are in the upper 40s and 50s, not what you usually would think when we're talking, about thunderstorms. But in this case, it's all relative because although temperatures aren't as warm as what we usually see to support thunderstorms, we have very strong winds. We're still in early March, so you have that, what we call synoptic winds, to kind of compensate for the lack of, say, instability. And one thing we look at when we were that prior question, we're looking for a parameter called CAPE. Tori touched on this too. This is an example of what we look at most unstable CAPE here. And you see this red line, this is about 100 to 150 joules of instability out in, say, eastern New York, right where this line of heavy showers and embedded thunderstorms are crossing this area here. And we actually have, if I plot up the watches and warnings, we do have a severe thunderstorm watch in this vicinity, right where that instability is kind of maximized. Now, again, a lot of times in the summertime, we're talking about a 1,000, 2,000, 3,000 joules per kilogram of CAPE, which is quite high. And in this case, it's much lower. But the important thing here to remember is we have extremely strong winds in, say, the upper levels of the atmosphere. So if I go to, say, 500 millibars, and we're looking at, roughly, over 20,000 feet, 25,000 feet in the atmosphere, you can see these triangles here. Each triangle, I know it's small, but it represents 50 knots. So where you see two of those together, that's 100 knots. So right in this purple shading here, you have 100 to 120 knots of wind, making up for the very limited instability. So you can still get away with, say, severe weather and thunderstorms, even though your instability isn't what you normally would envision for, say, later in the spring or summer. And one of the things we also look at, there's different types of instability. We tend to look, especially for these earlier season events, looking at where the cape is down low, and it's called roughly the 0 to 3 kilometer cape. So you're really looking in the low levels of the atmosphere, and look how that correlates to where this line of thunderstorms is right now, across the Pennsylvania and into the New York area. And I can kind of scroll through here, going up 0 hours, 2 hours. Look at that instability that actually pushes into Western Mass over the next couple hours into Connecticut, and then somewhat weakens as it continues to move further east. So we are monitoring the potential for heavy showers, embedded thunderstorms with locally strong winds as this activity continues to move east. And that's going to be the forecast dilemma into the later evening hours, how well the thunderstorms hold together as they move east. Because this time of year, like you said, we don't need a lot of instability for this activity to maintain itself. And one of the things we also look at quite a bit is the HREF model. This is an ensemble of different reflectivities from different models. So this is like looking at what a radar may look like 12, 24, 36 hours from now. So this was the model that ran at 12Z. And this is kind of one simulation from one of our models here. This is around 2, 3 in the afternoon. That was the rain that came through. And now watch, we're getting towards 7 o'clock. And this is the area that's really starting to kind of blow up here in New York as it moves east. Now you see that this simulation weakens it a little bit. So that's one possibility. We could look at another simulation here as we go through. If that holds it a little bit together, that's 3Z. Notice where that sharp line is, right across central Massachusetts into northeast Connecticut. So 3Z, we're looking at about 10 p.m. That's where this model simulation has it. And you can see these simulations all kind of give you a similar idea, but they differ too. You can see one of the models weakens it a little quicker than the other, and that can make a big difference in the eventual outcome. But when you see kind of the models coming into some type of consensus, that's giving you a better idea of what might happen here. So you can see that right into the central mass area around 3Z. We'll have to kind of see how that all holds together here. So let's take a look one more thing here. This is the current severe thunderstorm watch that extends roughly from the Philadelphia area up to the New York area. If you go to the Storm Predictions website, spc.noaa.gov, there's a lot of really good information. So this is actually where the current watch is, but they issue mesoscale discussions out ahead of that. And that gives you an idea of what they're thinking is going to evolve. So here comes the what we call squall line. And keep in mind, you don't need lightning to produce these damaging winds. There are occasions where we will issue severe thunderstorm warnings because the main threat is going to be the wind. There may be very limited lightning or hardly any lightning at all, but the main idea is to get the message across that this activity contains damaging winds. So this is basically a summary of what they're expecting to move into western Massachusetts and Connecticut. A narrow line of low tops, a squall line continues to move into central New York and PA with a steady flow of reports from wind damage. Again, getting that verification from the field is very important. And they're talking about, nonetheless, strong synoptic forcing for ascent remains along the trough as it moves east. So despite evening stabilization, which means very limited instability, we're able to compensate from it for the strong wind fields. Either way, behind this front, we're looking at a sharp drop in temperatures and some strong winds. That's why we have wind advisories posted as this line moves through, whether there's any thunder in it or not. We're definitely going to be dealing with 40 to 55 mile per hour wind gusts. So don't be surprised if you go to sleep and you hear the wind roaring about an hour or two later. And with that, we'll go through a really brief overview of what to expect here over the next week. So I'll start here. This is the European model. This is a look at the current surface low pressure system. This was a few hours ago. Strong low pressure across the Buffalo area. And as we advance here, you'll see that lift up towards New England. And notice whenever a surface low lifts to your northwest, that means you are on the warm side of the system. So no surprise, temperatures are still in the 50s. And as that crosses, again, here's the line of showers moving off the coast. And behind that, winds blow counterclockwise around low pressure. You get in a much colder, blustery air mass. Tomorrow will be quite breezy with temperatures only in the 40s. And talk about how quickly things can change in New England. We get a high pressure moves in, built in tomorrow evening, so the wind will diminish, be a quite cold night. Lows in the teens and 20s across the region. And now look, we have a low pressure system approaching from the southwest. Now this will be a relatively weak system, but it does look like we're going to see a bit of snow come later Wednesday into Wednesday evening. Fortunately, temperatures will be actually above freezing when this starts. So it will be snowing in a lot of places, especially south of the Massachusetts Turnpike. But a lot of it will actually be melting on paved surfaces. As the sun sets Wednesday evening, we may see some roads get slush covered, but probably more of a decorative snow instead of a high impactful events that we've seen a couple times this year. And then behind that, what you'll see is as we move along here, it's relatively quiet and dry Thursday. And as we move along Friday into Saturday, you'll see a couple areas of low pressure here developing in the Ohio Valley as a very cold air mass dips down into the central United States. In response to that, remember the atmosphere is always trying to stay in balance here. We're going to get a warming trend again across New England. And look what happens as we head towards the weekend here. This low pressure system is going to ride up. And now this is the European model. It has a 980 millibar low. That's actually a fairly strong low pressure system and actually has fair amount of snow not too far west from us. We'd still be pretty much rain, but parts of New York and northern New England would see significant snow out of this. We'd be seeing rain, wind, mild temperatures, and then maybe a turn to much colder air Sunday into Monday. You can see that as the low goes by, it's going to pull down a lot of cold air from Canada. So remember this track here because I'm going to switch to the GFS model and we'll notice a bit of a difference here. So with that, let me switch to the GFS model. And with that, a lot of these models you'll see they'll tend to be in a very good agreement in the short term. And as you go out in time, you may see more disagreement amongst those models, which gives you an idea of the uncertainty. So here comes the Wednesday system again. It's a weak system. You see the lows only like 1,000. Well, there it's 1,006, 1,003. It's moving off. So a bit of snow, probably again, not much of an impact. And then kind of quiet Thursday, quiet and dry. And here comes, we got the big trough coming out into the central United States. But now watch the track of this low pressure system here. It's a good, I'd say 100 miles west of where the European had it. So what does that mean? Well, it means a warmer solution. So while we're pretty much rain anyway, Albany or, parts of New York State that had a lot of snow in the European model are mainly rain here. And again, it's too early to decide which one's going to be correct. A lot of times it ends up being a blend of both of them, but it's just gives the forecasters an idea of uncertainty, and that's stuff we utilize when we put these forecasts together here. So something to keep in mind, but this does look like a strong storm. You see this low pressure system dropping below 980, 974 millibars as it lifts into northern New England, and then look at 961 as it enters the Maritimes. Whenever you see a strong change in pressure like that, you can expect strong winds. So we may have some strong southerly winds out ahead of this, and then strong northwesterly winds behind this. So don't be surprised to see some more wind headlines come this weekend. So that's something we'll be taking a look at over the next few days. A turn to colder air Sunday and Monday of next week. And I want to show you one more thing. Best way to kind of follow the upper to tell if you're on the warmer cold side of a system is just looking at the 500 millibar height fields. What we say, you're looking, say, over 20,000 feet up in the atmosphere, and kind of get an idea where the wind's coming from. So let's go ahead here into that where we see that big trough form as we get towards the weekend. Notice you have this big trough here. So in this area, you're looking at below to well below normal temperatures. And then on the east side of it, where you have, say, ridging, it flows from your southwest, you're usually going to have above normal temperatures. So again, we're going to warm up towards the end of the week. Wouldn't be surprised if we break 60 again on Saturday, and then much colder Sunday, probably highs in the 30s. And then most likely after that, we're going to start to warm up again as we get later into next week. But that's plenty of time to figure out what's going to happen there. But certainly quite the active weather pattern through the weekend. So with that, I want to thank everyone for joining this webinar. Again, we're actually going to have another webinar Thursday night, and that will be on the mixed precipitation event, freezing rain and sleet, that we dealt with about a month ago. So that was a significant icing event, even though we did not get much snow. It doesn't always have to be snow. And again, thank you to everyone. I appreciate you bearing with us for the technical difficulties we had during the beginning of the presentation. And thank you, Tori and Andrew. Great presentation, great job, Tori, with handling that event, and definitely some adversity during that event, but got the information out, which is the key. So thank you, everyone, and have a good night.